Good evening. Good evening. Today's topic is supervised learning. Okay. In the previous lecture, we have gone through the machine learning types, supervised and unsupervised, and reinforcement. Now we are going into the details of what are those supervised learning, and in the coming up lectures, we are taking up its maths and its examples. Let's start. What is supervised learning? The roadmap for this particular algorithm is the supervised learning is basic concept. We will cover it today. Next, we are going for decision tree induction, how decision tree works, evaluation of classifier, what are the rules based on this classifier, classification using association rules, the rules we define in the chapter lecture number 4 coming up. Then the important algorithm. Those are Naive Bayesian classification, naive Bayes for text classification, support vector machines, k nearest neighbor, bagging and boosting. Uh, uh, these algorithms, which are this one, naive Bayes, support vector machine, k nearest neighbor. These are the most important algorithms. We frequently use these algorithms, mainly the support vector and k nearest neighbor. So, an example why we used supervised learning. What is the example behind this one? An emergency room in a hospital measures 17 variables. Example, blood pressure, age, and so on, of newly admitted patients. Okay. A decision tree is needed. We need to take the decision on the spot whether to put a new patient in an ICU, intensive care unit. Due to the high cost of ICU, those patients who may survive less than a month are given higher priorities. This is the question. Problem. What is the problem? To predict high risk patients and discriminate them for low risk patients. Okay. What is the problem? What we want to do from this scenario, from these rules, to predict high risk patients and discriminate them from low risk patients. Another example is a credit card company receives thousands of applications of new cards. Each application contain information about an applicant. Those are age, uh, his or her status, annual salary, outstanding debts if any, credit rating, and according to the company what they want to know they can ask. That comes under etc. What is the problem behind this one? The credit company, how it is going to allocate or issue a new card to a particular client, to decide whether an application should be approved or to classify application in two categories, approved or not approved. Okay, whether problem is whether an application should approved, and what are the categories? Two categories are approved and not approved. Machine learning and our focus. Why we want to do this type of, how we can tackle these type of problems. Like human learning from past experience. These we know. This comes under machine learning. A computer does not have experiences. That also comes into this. A computer system learns from data which represents some past experience of an application domain. That is machine learning. What is our focus then? Learn a target function that can be used to predict the values of a discrete class attributes. For example, approve and not approved in our previous example of credit card, high risk and low risk in the example of patient, whether to admit it his or her in ICU or not. The task is commonly known as supervised learning or classification or inductive learning. Why it is known as classification? Because we are classifying the particular into two categories. Means one is approved credit card and another is not approved credit card. In case of patient of high risk and low risk. That comes under supervised learning. Now, there are two things that has to keep in mind, that the data and the goal. What is the data and what you want to achieve from that data? A data of set records, also called examples, instances, or cases, described by k attribute, a class, attributes a1, a2, ak. Class each example is labeled with a predefined class. Means you can take the class like approved, not approved, healthy patient, non-healthy patient. That is a class. Goal: to learn a classification model from the data that can be used to predict the classes of new cases or instances. For we will continue the example of patient. We have the two class, means the person whether he has to be admitted in ICU or not. This is a class. Yes or no. These are the classes. In on if a new patient get admitted in the hospital, according to his symptoms or condition, we will decide whether to put his or her into a class of risk, high risk or low risk. This is an example of approved or not approved. Means loan application. Age ID, age, has jobs, has his own house or not. Credit rating, class. Means age is young, job no, false, own house false, credit rating fair. Though whether we are going to approve or the card or not, no. Yes is young, has the job, own house, no. Credit rating is good, we can approve the card for him or her, and so on. We have the 15 entries into this particular data, and we have, you can see, no and yes according to the these features. We have 6 no's and how many yes? 9. Okay, this is the two classes, yes and no, and we have the data in those particular classes. Another example is the learning task. What we want to learn. Learn a classification model from the data. Means what we want to achieve, how we want to classify the data. Use the model to classify future loan application into yes and no. We have done in the previous slide, yes and no. We have to classify the data into the yes and no. The no class data, they can be for in future can be grouped into yes class if they are having job, or if they are having these two things good, they can be converted to the class from no to yes. Okay, we can't discard these classes, we just not taking into account at this particular moment. What is the class for following case instances? This is the case instance, you should all taken see this. This is the case instance from the previous example. What is the class, no or yes? Age is young, job is false, own house is false, and credit rating is good. Whether we are going to approve his credit card application or not. Answer me.
No,
Whether we
sir.
are going to approve. No. Why?
No, sir.
So because
Mhm.
sir, because of not getting a job, not having a own house, and the credit rating is also good, but not excellent. So that's why I think.
Because might be credit rating is good because he is owning the money of his parents or something else. Okay.
Okay.
Right now, for example, you people, you are not working anywhere.
Yes,
Do
sir.
you have your own house? No. But your credit rating is good because in your account the money belongs to your parents. That's why your credit rating is good. If you have a job or own house, then class is also approved. And otherwise not.
Okay, sir.
Okay. This is the example, general example. So what is supervised and unsupervised learning then? Supervised learning is classification is seen as supervised learning from examples. We have to see the examples. We have seen the examples, three examples. One is patient, one is loan approved, and another we have reduced by ourselves by taking this into the account. So what is supervised means the data are labeled with predefined classes. It is like that a teacher gives a classes. Okay, this is means we know the teacher is going to get the class. The classes is given by teacher only. Student can't give the classes. Student is there to be taught. Mean there are two classes, teacher and a student. So they are labeled accordingly. test data are classified into these classes too. Means the new data that comes to our model has to be classified in these categories only. Whether the teachers, or we can take the previous example, approved or not approved, approved and non-approved. So we will put the new data into these classes only. On the contrary, unsupervised learning is clustering of data. Class labels of the data are unknown. We don't know the data of, labels of that class. That is unsupervised. Given a set of data, the task is to be establish the existence of classes or clusters in the data. Okay. Given a set of data, the task is to establish the existence of classes or cluster of data. We have to make the classes by ourselves or cluster by ourselves. For example, in yesterday's example, we have seen that there is a like this. These are the cluster. Okay, these are two cluster. I am just coloring this one. Another cluster is green. I am taking the four clusters. It is intermingled along. I have drawn the pure, reduce the clear line in between. How these are clusters, why we are making these in a cluster. For example, these are random data. We have created a cluster like this one. This is first, second, third, and fourth. These are the cluster we have made. Means these are loan approved, not approved, pending cases, and uh, deficiencies in the documents. So these are the cluster we have made accordingly. So this comes under unsupervised learning. Okay, we are where we make the classes or existence of classes can be made by ourselves.
Yes, sir.
So supervised learning process having the two steps. One is learning, means training the data, and another is testing the data. Okay, what is learning? Learn a model using the training data, means the pre-existing data. We have the data, we have seen in the slide that we have the data of 15 clients, whether we want to approve or disapprove, not approve the application. That is the training data. Okay, and what is the test data? Test the model using unseen test data to assess the model. And what is the testing data? In the another slide we have seen, we have given you the scenario whether the person is young, house job is no, false, house is false, but credit rating is good. So that is the testing data. We are testing our model whether it is predict the accurate result or not, whether it is disapprove the application or not. That is the testing data. Training means the existing data, testing means the new data that we are giving, giving to the our model for testing purpose. So what is accuracy then? What How accurate is our model? Means number of correct classification divided by total number of test cases. Okay, total
Yes,
number of
sir.
test cases, number of correct classification divided by total number of test cases. Step 1 is training. Model is something in between of both the steps, training and the testing. Means training the data, learning the algorithm on which we are performing, then the model creation, then test data. We are giving the test data to the model, and then in the end, it is accuracy. This whole is known as supervised learning. Means data, we have the data. Training data means pre-existing data. We will apply the algorithm on that one, whether it is SVM, decision tree, we have gone to naive Bayes, any of the supervised learning. Then we create the model. We will give them the new data, whether our built model is good or not, and then we go for the accuracy. Then what do you mean by learning? What is learning then? Given a data set D, for example, a task T and a performance measure M, what it will do? A computer system is set to learn from D to perform a task T if after learning the system performance on T improves or measured by M. Means what a computer system will do, it will learn from D, from data. Okay, it will learn from data to perform a certain task. Okay, Task means whether to approve the loan application or not. That is a task. After learning the system performance, after learning the model, on T improves, on the testing data improve, on the task improves as measured by M. Performance. We need to increase the accuracy of our system. In other words, the learned model helps the system to perform T better as compared to no learning. If a system is learned one, then it will perform better than a system that is not learned anything. An example, taking into account the loan application again, we have the data. What is the data? Data is loan application data, the 15 client data. What is the task? Task is predict whether a loan should be approved or not. And what is the performance measure? That is accuracy. We have to do these three tasks: data, task, performance measure. No learning means classify all future application test data to be majority classified as yes. If there is no learning with our model, then it will classify all the majority cases into yes. Otherwise, it will give the accuracy correct. What are the yes? We have calculated yes in our model. That is comes to be 9 and no is 6. So what we are doing? We are calculating the accuracy. What is the formula of accuracy? Number of correct classifications by total number of test cases. Means total number of correct classification is 9, yes, and divided by 15, that comes out of 60%. Means our model is 60% accurate. Our model is predicting 60 at a accuracy of 60%. We can do better than 60% with learning. Fundamental assumption of learning. What are the assumptions? Means the distribution of training example is identical to the distribution of test example, including future unseen examples. Means we can't distribute randomly. There are two: training and test. There are two data types. So we can't distribute data on uneven basis. Means there is a 60, here are 900 cases, and yes, in training data, and in test data, there is only 10 cases. So it will always give you a unbiased biased result. Okay. So data should be on a identical manner. Means if there are 900 testing case, so there should be a test case of even 600 or 700. Then it should be a, it will perform, it will give you a good accuracy. In practice, this assumption is often violated to a certain degree. Strong violation will clearly result in poor classification accuracy. If we ignore this one, if this is the case 900 versus 10, it will always give you a poor accuracy, because total number of cases 900 and yes is 10. What will be the accuracy then? So it will be not good accuracy. To achieve good accuracy on the test data, training example must be sufficiently representative of the test data.